and welcome to day 2 of IoT Design Week, part 2.
Part 2.
Today we are talking about artificial intelligence, and this is our first ever double live stream.
Yeah, it's exciting.
So if you joined us this morning, thank you for coming back. My name is Rachel Bedore.
And my name is Clifford Swartz.
And we have some really special guests Skyping in today. So first, from Microchip, we have our Wizard of Make, Bob Martin, Skyping in from San Jose. And then we...
Hello all.
Yes, hi, how
Howdy.
are you? We also have Adafruit. Hi guys, thank you so much for joining us. Hi, so they're Skyping in from New York, very special guests. We're so lucky to have them on.
Absolutely.
And in honor of that, we will be giving away 5 Edge badges. So 5 of the Adafruit Edge badge, TensorFlow Lite for microcontrollers. Clifford has one right there.
Right here.
So to be eligible, just fill in the survey that's dropped. Why don't we take it back to the booth? They can give you a little bit more detail.
Hello, everybody. How are you doing? Lovely afternoon. Kind of overcast and rainy here in Chandler, Arizona, but
Yes,
I'm pretty sure it's
absolutely.
got to be much nicer over in NYC and much, much nicer over in San Jose. But, you know, we're happy to be here. I'm Wayne Freeman.
I'm Daniel Ho.
And see, we're basically playing musical chairs today. But we got some exciting material here. We're super happy to have Lady Ada, the one and only, and Mr. Lady Ada as well, joining us. You know, just a couple of housekeeping things. As always, basically to get one of the 5 TensorFlow badges, 5 edge badges, we're going to basically put a survey in the comments of our chat in LinkedIn and YouTube, and the first 5 people will win.
The first 5.
First 5 will receive the Edge badge. Now, from yesterday, we had 5 winners, and I actually want to congratulate them. They've been contacted.
Oh.
I'm not going to mention last names, but if you're on right now, I'm going to say shout out to Dan. Yes, I have a list because I'm old.
Oh,
Shout
no.
out to Dan. Shout out to Chiang. Shout out to Vaishnav. Shout out to Jaime. And shout out to Nick. You guys should have some awesome home automation kits on the way at some point in the near future. So as I said, we're all on these 3 platforms.
Yep.
Please like, share, subscribe. And let's see. Am I missing anything, Daniel?
Well, I was on the previous session this morning. There is a lot of good questions coming from the chat, so we're looking forward to those in today's session.
Yes.
Yeah.
And by the way, if you have questions in the chat, so you know, Daniel and I are gonna, you know, kind of take it, take it easy. We're gonna have a conversation between Bob and Lamar and Philip, and I think the Adafruit team is going to be taking care of a lot of the chat, bringing some questions out of the chat. So please, hit them up, ask them questions. You can also ask me questions. You all know me. Ask Microchip technology questions as well. So without further ado, let's take it back to the stage.
Thank you very much.
Great. So yeah, why don't we just start out? I think Bob's going to be interacting a lot and asking a lot of questions, so you might hear a little bit less on the stage than you normally do. But you know, we got to switch it up. We have 7 live streams this week.
Right.
Right.
Yep.
So Bob, do you want to take it off from here and kind of introduce the topic and introduce Adafruit, that kind of thing?
Yeah, certainly. Be glad to. So I've been, Adafruit. Lamar and Philip and I have known each other for quite a few years now through Maker Faire interaction, and I remember at the beginning of when they were introducing or bringing CircuitPython into the realm of the microcontrollers, and so now that's expanded over to what I consider a really nice perfect storm of usability. So today we're going to be talking about not only the CircuitPython leaps and bounds they've made, but some of the later machine learning stuff. And on top of that, the really easy to use IoT, framework, Adafruit IO. So all of these, again, are based on either a SAMD21 platform, which is a Cortex M0 from us running at 48 megahertz, or a SAMD51, which is a Cortex M4F running up to 120. Obviously, different horsepower for different things. So I think I'm just going to hand it off to over to Limor and Philip right now, and then we'll banter back and forth. We'll see what some of the questions come up, but again, this is just to really coalesce the messaging that they're trying to get out, and in terms of Python coming in on the back end, obviously for the rapid prototyping, there's some very compelling things that they're going to be showing you. All right, over to you two, New York.
Hello. All right, it's me, Lady Ada. With me is Mr. Lady Ada.
Hello.
And yeah, we're in the factory. This is where we do all our manufacturing for electronics. You can actually see people who do run the manufacturing equipment. It's 6 o'clock, so they're packing up and going home.
Yeah.
Gonna watch
I should
some Netflix.
mention we are, until someone on Twitter tells me I'm wrong, we are the only USA woman-owned manufacturing company. That's it. And we make all the things that we're about to show here in the Adafruit factory right in New York City.
Yeah.
So
Some of these are like
doing this.
warm from the oven.
Yeah,
We just turned off the oven.
If you look in the background, Lady Ada sits like right over there, and then what you hear in the background is multiple pick and place machines, giant reflow oven.
Yeah.
We have selective solder machines, so we do all of this in Soho in New
Yeah.
York City, and this is one of the few places that you can actually hear and see a factory.
Yeah. Very exciting. This is where it all happens. The magic.
Yeah.
Okay.
So we're today talking about AI, and you had a very different approach with how we're doing machine learning, also I/O. But to kick this off, do you want to talk about what we've been doing with TensorFlow and some of the things with the Microchip chips?
It's exciting. So TensorFlow Lite runs on, it's basically designed for mobile. TensorFlow Classic kind of runs on desktop machines, and then they're sort of like, okay, we can make it like 2 or 3 times faster, and TensorFlow Lite and optimize it a little bit. There's other machine learning and AI platforms, but TensorFlow just happens to be one of the most popular right now, which is why, I think it matters. I think when people see Google, who designed the TensorFlow system, when they start getting into something, it's like they're just a big player. And so about like a year ago, I think, Pete Ward.
Yeah, Pete Warden was working
Pete Warden
he was
and
working on his book TinyML.
Daniel S.
Yeah.
They're 2 TensorFlow team members, and they said, hey, I think we can slice down TensorFlow Lite even more. Obviously, you wouldn't be doing training on device, but you might be able to do retraining, and you definitely could do simple inferences. Basically, maybe like a wake word detection type thing.
And folks have been calling this like edge computing. That's one of the other ways it's been described, because it's a disconnected, it's not an internet connected AI device. It can do some type of machine learning, can run some models.
Right. But it is
trained
very
models.
minimal. I just want to make sure people know it's minimal. Like you can't do you can do some facial recognition on some platforms, but it's very like narrow. But if your application is narrow, say you want to do sensor pattern recognition or some audio recognition, a popular thing that people like to do is gestures, especially when you have a motion sensor and you want to take that motion and you want to detect gestures with it, which is extremely hard to do with kind of classic programming style. But with like TensorFlow Lite for microcontrollers, it's trivial. You just train it with like 50 gestures that you want, do 50 times over. You tell it this is what you want. It actually does a pretty good job. We have a demo that comes with TensorFlow Lite for microcontrollers for gesture recognition using accelerometer. We also have a speech demo. The speech demo, again, it only can detect from a couple different words. It's like a wake word detection. So not necessarily detecting whole sentences, but can detect when it hears a certain sound or word, and does a pretty good job. As with all machine learning, it really does come down to your training and your data and how you manipulate the data, and that's beyond the scope of this video. But there are books about it. There's a TensorFlow Lite for microcontrollers book, so check that out. And what's neat is that they really just targeted any Cortex M4, M0 Plus chip. I will say you really do want to have an M4. The M0, I mean, you can do some basic stuff, but if you really want to do the demos and feel happy about the experience, you really want the M4 because it takes advantage of the FPU. There's a lot of math. You're multiplying a lot of matrices together and doing stuff with them, FFTs, etc. Having the FPU is pretty sweet. So that's why I like the SAMD51 in that case, because it's fast. It's got tons of RAM, which you need. You need RAM to store your data. You need a lot of flash to store your model. It has the computation. I like overclocking the SAMD51, but even at 120 megahertz, it's very fast and chipper. And you can use the DMA channel to get your sensor data in, and then do the processing in the background. So that's the introduction. Do you want to go to some demos?
Yeah. What do you all want to do next?
Well, I could show some demos I've got here for the.
I'm gonna switch over to the demo station.
Yeah, let me unplug this little fellow. So let's see which demo this is running. Live demos are always exciting. Okay, so this is actually the Edge Badge demo, and what I really like about, this is a Pi Badge demo for gestures. So on the back we have an accelerometer, and here's the SAMD51, and it's got plugs and cables for extensions and stuff. What I like is that we have a screen, and the screen allows us to have information and feedback, and especially when you're starting to practice with TensorFlow Lite for microcontrollers, it's really good to understand whether you succeeded in an inference or not, and maybe what the percentage match you got for your data inference. So this demo is gestures, and it's been pre-programmed with a W gesture, which is like a up, down, and then a slope gesture, which is sort of like an angular, and a circle gesture. So let's try the circle. See if I can do that. It might require me to have it actually held up because it was.
Yeah, if you want to hold it up and then.
Maybe I'll hold it
move it
up.
around.
Yeah. Okay. Hold on. So this, and then I got it in time. So it's I forgot because
Live demos.
it's not axis in specific. Like I actually can't do the gestures when it's flat because it's designed to be held up this way. But then if I do it, I'm gonna bang into this nice camera. So let me try the W next. So let me just W.
Yeah.
Okay.
Nice.
So
So I'll actually switch to Lady Ada for a second, and I'll show you what she was doing, not on the overhead.
I know. I feel like
But
it's,
on, well, it's not a magic trick or anything.
it's not magic.
So I'll switch over here, and you can see the shapes. So when she did O,
Okay. So
she made a circle.
oh shoot, hold
and
on.
then W.
Sorry. Okay. You know what? I need a longer cable. Didn't think this one through. Hold on.
You're good.
Okay.
There we
There
go.
you go. Okay. So now let me do O, which is clockwise, which means I have to do counterclockwise here.
Oh, good work.
So if we go-
And then go great. And then the
Yeah.
W, which is this way. So this is just taking accelerometer data. I think it's just
There we go.
W. There you go.
Yeah.
Okay. So this is just taking accelerometer data, and again, gesture is a common thing that people want to do machine learning with because it's so hard to do otherwise because there's just so many variations and trying to detect gestures other than basic pedometer gestures. I think it's interesting, has a lot of promise.
Yeah, one benefit of this, well, there's a few. One is it doesn't need to be internet connected. A lot of machine learning thinks it's sending it somewhere else, doing processing and sending it back. So it can be low power.
Yeah.
There's lots of neat things you can do with this. I do like the constraints of edge computing because it makes you think about what you're doing. The other thing that we did, and Moore could talk a lot about this, is we made it so anyone can use it. The models and the way you have to train the stuff and put it in, and if you want images. So a lot of times you might have someone who is hearing impaired. So can you have a screen that has something for them? Maybe someone's vision impaired. Can you have a word speak?
Like audio, yeah. You want to have
Audio.
different feedbacks. That's also important for user experience too.
Yeah.
Sometimes people will be using your product and they might be trying to use and do an inference, but they're not looking at the thing, so it has to be audible. Or maybe they're in a really loud factory, and so they're not going to hear an alert. So
Yeah.
having it be visual. These are parts of the user experience that as you do your TensorFlow Lite for Microchip project, you'll probably want to think about it. So it isn't just a small LED lighting up. You want to have a little bit more feedback.
The other thing we did is we took a page from what we did with CircuitPython. So when you plug our machine learning devices, and you can run it on lots of different things, but if you're using an Edge badge or a Pi badge, when you plug it in, it shows up as a USB drive. And
Yeah.
you can drag and drop the models that you've already made. You don't have to use an IDE. You don't have to compile. You don't have to get a bunch of errors. And the graphics and the audio, those are also standalone little images.
Yeah.
So it makes it really easy to know, even if you're not a programmer, you can still work with a model that someone has made for you. You can still make the graphics. You can still make the sounds.
And that's important for TensorFlow because actually the compilation time for TensorFlow Lite for microcontrollers is not trivial.
Yeah.
It is like a few minutes, and if you had to do that every time you want to try a new model, I think it would take you a lot longer than when you train. You're using Colab or something to train, then you drag the file over. So we take advantage of the
Show another demo?
USB. The lots of endpoints available on the MD51. So we have serial output, we have mass storage for dragging and dropping files, as well as any other USB interface.
And this is going to pick up a bunch of background noise. However, you'll still be able to see some of the things that we can do with voice.
Yeah, I put it on a very low. It's on a very low limit because I didn't know how good the audio was. Yes. Yes. Okay.
I don't know if you can. Yeah, I don't know if you can hear that, but the device itself also said the word yes.
Oh, I did not hear that.
Yeah.
Oh, that's cool.
And we did that because we wanted people who might be vision impaired to get some type of feedback as well, that they were successful with testing the yes/no demo.
Right.
There's also other words that we've experimented with. You have to do a bunch of work to make them work, but we did things like dog and cat. And so when we were testing this in our apartment, I'm sure the neighbors thought we were weird because we just kept saying cat, dog, cat, cat. And we don't have a cat or a dog right now.
And one of the things is, for example, like when it's searching for looking for the word yes, it actually does a much better job than the word no, because there's like twice as many example files for the yes speech than no. And so that's something that is important to note when you're doing model training and inference. Is it really, really matters how many data points you have and the variety of data points. And it's almost more important than the computation. A lot of people are like, oh, I need to have like a ton of computation. It's actually about whether the quality of your model inputs are good and are constrained over like what you want to detect. So I think like as people are doing this, first off, it's quite early. And I will say it's not, it's definitely not perfect. It definitely has inference, mistakes. It has false positives, false negatives. But if you're just trying to use it as a tool for your sensor inputs, I think now's a good time to experiment with it. I don't know if it's quite ready to be put into a product, but having it be one of the tools, and as chips get faster and RAMs get bigger and our models get larger, because again, the larger the model, also more RAM, more model, more data, you're going to get better results. So these are all the little trade-offs. It's early, but I think it's fun to play with, and I think we're going to see people start to experiment with how to integrate this into user interfaces.
Some questions were in the chat. Do you want me to start reading them off?
That'd be cool.
Go for it.
Okay.
Yeah, because there's a couple that, well, one of the ones that I expected to show up, and you probably got the same one on your side, is what's the sweet spot for some of the memory footprints, say for that voice inference. And the other thing, if you could speak
more.
Yeah, yeah, more is always better.
More is good, yeah.
And the other one, have you found inference engines more suitable to this type of squash TensorFlow Lite, or have you played around with, more than Colab?
I've only used Colab, which is pretty much the standard, and also it's the easiest. I've played a little bit more with it on like a Raspberry Pi type computer where you're actually running TensorFlow Lite proper, because there's some really good models that people have released for TensorFlow Lite, so you can kind of hit the ground running. For RAM usage, I think like 64K is a minimum, but it really depends on the size of the model and how much data you're buffering. So I don't, it depends. Like the sine wave demo, I think is maybe 4K, for example, just does a sine wave, like it's just input output, one floating point to one floating point. That's a really simple model, so that's minimal. But I think like there's a detection for a camera that can detect if there's a person in front of it, not which person, but a person. And I think that's more on like the size of like a 50K, 60K model. Okay. So yeah, they do get chunky. Sometimes you can put them in, if the model itself doesn't go into RAM, it goes into Flash, because you're reading to it, you're not writing to it, so it can be in a read-only memory, but you'll still need to process that data. So yeah, you'll really want the core M0 plus. I mean, I know it runs on some M3s, but I think an M4 is is where you're going to be happiest. And you can always downgrade once you've figured out the performance you need.
Right. Would there be any possibility of storing inference models in, let's say, external SPI flash and then pulling them in? It'd be slower.
It's not supported at this time. I mean, if you had like an execute in place that was smart enough, but honestly, I think you should just stick it in. If you have flash memory, put it in your flash memory. That's what we do. We actually, the second half of the SAMD51 flash is where we stick the model. So we load it from mass storage, burn it into the flash, and then, and then pass a pointer in and say like, hey, here's your constant variable connect, it's huge, but go for it, and it runs fine.
Right. All right, good
that's
enough.
in the TensorFlow Lite core. You'd have to, if you wanted to support a different type of storage, they would have to add hooks for that, and there isn't anything right now. They actually want it to be like programmed in as a header file, so the fact that we're putting into Flash makes it is a little bit different. Okay, cool.
All right, have you guys got any flash coming in there, or questions coming in there, I guess?
Yeah, I see a few. I can, one's a little bit off topic, but I think we can still answer it. So someone want to know any plans for a joint PIC and CircuitPython project? I will answer this for Microchip. Here's the good news. We have 116 boards on circuitpython.org/downloads, and more than half of them are not from Adafruit. So anyone from large companies to small companies to individuals can work on a port of CircuitPython. Sony recently did, and there's also
the NXP chips coming in.
Yeah, NXP. There's a port for that.
Tons of ST chips
started in the community as well. And so the answer is it all depends on the different companies that want to do it, but it's possible. It's not like other things.
Yeah,
that would be impossible.
I will say the TensorFlow Lite is Cortex based. It's there's a lot of optimizations that are designed for Cortex M4, M0 plus chips. So I don't think it would run on like a MIPS chip or anything without a lot of work. Or if it did run, it would run very slowly.
Yeah. So that's for TensorFlow. So
yeah,
I also want to know about CircuitPython.
Because I was about to ask, like, can I run this stuff on a PIC-32? It's like maybe, but it's not designed for it.
So I sort of answered it for Microchip, but is that accurate? Like, is that accurate? Like, it's a possibility.
Well, I'll just say that I telepathically communicate with Clifford. He says he's going to pick it up with him for his pet project. No, I actually don't know. Do you guys know in the booth if there's any plans for that? But it sounds like it's an opportunity that's open.
Yeah, it's definitely an opportunity, and it's something that I think we're well, technically bound to not say because it's a future product.
No, that's why I answered. No,
exactly.
So thank you for answering, Philip.
The good news is other large companies that make chips are looking into this, so anything's possible, and that's why we made it. We wanted to make sure that if it's interesting, you don't even need to talk to us.
Yeah, I mean, the chips that are coming out, so like people keep asking, like, why would you ever want to run interpreted language on a microcontroller? And the answer is your microcontroller is just way too powerful now. You have way more flash and memory and capabilities than most people need. So you might as well spend that free, like you can't get a chip with less than like 32K of RAM these days. And if when you do, it also comes with a ton of flash. So having interpreted language, helps manage the intense complexity of chips. Like I, used to program like a PIC 084 like everybody else. And like you could write it in assembly and you could actually like get stuff done. That's not possible anymore. Like you can't, I don't even think there's boot code for an ARM Cortex chip in assembler if you wanted to. It's like, no, it's all wrapped up in SimSys. You have to use multiple layers. So if you're gonna use multiple layers, stick an interpreted layer on there. Yeah.
Okay, next up. Question for Adafruit. Where would you like to see machine learning on microcontrollers, like the Edge Badge, a year from now?
I think in a year from now, it's going to be a massive change. So I think a lot of companies are going to start sticking custom, like neural net specific processor subunits into their chips. Like ARM's talking about it. ESP is putting a RISC-V submodule in there, and I think it would be easy. It's easier with RISC-V to add custom commands that would help, like do TensorFlow Lite and other neural net calculations. I mean, FPU helps, but like, if you could say, hey, here's like two matrices, multiply them together, and give me the result in another buffer, and have that be completely done in hardware, that would speed up things a ton, as well as other like common mapping and reducing things that people do in TensorFlow to adapt the tensors as they flow through the TensorFlow. And I think what's going to happen in a year is we're going to see a lot more announcements of people like, okay, so we took the SAMD51 core and then we took like a RISC-V chip. I'm not saying the Microchip's going to do this, I'm just saying an example. And we stuck them together, and here's like our AI Edge chip. And you get all the peripherals and the memory and the fun stuff and the compiler that you love with the SAMD51. And you can use that to drive a display and play audio and do the UI and touch controller. And then for the edge computation, you have this little RISC-V subcore that you send, like a FPU basically, but like an NNPU, like a neural net processing unit, and it returns it back. And then you just have to optimize TensorFlow to look for those special commands. And like if you compile TensorFlow for an Intel computer, which like I did like 3 times, which totally sucks, and don't do it. As it goes through, it says like, hey, the processor I found has these instructions. I'm going to take advantage of them. And then once you do that, you actually can't move that TensorFlow installed to another computer because it won't run, which I found out, which is why I had to compile it 3 times, because it's really optimized for looking at these exact instructions. So I think that's what's going to happen in the next year or 2.
Okay. So I've got one coming in, which is kind of very relevant to more of our general audience on whether TensorFlow Lite is ready for industrial / mission critical applications. And I think that rolls back into, I don't know, and maybe you two at New York know, that there's inference level confidence levels. I mean, obviously, variations of TensorFlow Lite or whatever Tesla's running or the EVs are running, that's inference models, but those have been tested and tested and tested. So I honestly don't. That's going to be much like when we engage with mission critical customers. A lot falls on them. Are they coding against MISRA coding standards or all the boundary conditions they need to test? In the general sense, that type of mission critical testing needs to be decided on by the customer as well. But I was just wondering if you had any other comments on, do you see in the TensorFlow Lite arena standards or type of inference confidence levels or things that would be more generally acceptable by mission critical industrial applications?
I think we'll see consumer applications first, where you're using TensorFlow Lite on microcontrollers for something like a low power wake word detector, but then hands it off to something heavier and more, it'll do other things. It's unknown at this time if people are deploying TensorFlow Lite on, hobbyist level things like our
I could definitely see medical equipment eventually adding machine learning to it to try to do pattern detection that normally you'd have a human, of course, always as a backup, but as an early detection, because like definitely right now there is some pattern matching and modeling, but I think it's just yes, you can, the alternative is you have a human write the pattern matching code, but humans are also flawed. So it might be a combination of both.
Yeah, like we have, this is basically a full-on development board that has everything broken out and NeoPixels and all this stuff. When you're going into an industrial setting and manufacturing, you wouldn't use all this stuff. So what we see from our side is a lot of engineers using this to get going, and eventually when they go to manufacturing, they're using a smaller set of components. You certainly wouldn't deploy a badge into an industrial setting. This is just to get developers able to, you could plug Wi-Fi into this if you want. You could put a whole bunch of different sensors. We have, for instance, a thermal camera that you can plug in on this and do very basic people detection. If you were going to put this in industrial machinery, you obviously wouldn't want a cute little snake on it. And stuff
I
like
think
that.
if you
I don't
So
know.
I think, yeah.
And I think of it, people are now definitely doing IoT machine learning analysis. Like they get IoT data and they analyze that data and they train on that data. And just eventually that just trickles down into the final product device. That's, I think, maybe 5-10 years away. But it also needs to have a really good use case. Like right now, the use case for a lot of machine learning is voice recognition for voice assistants. I don't know, people who are making industrial and medical equipment have to decide what's the problem they're trying to solve, and it doesn't make sense to use machine learning. Probably more likely than Bitcoin.
Yeah.
Okay.
Okay.
And
other questions? Okay.
We had just one more, but I think we've touched on it a couple times on, again, back to the facial recognition. And it's, again, we're at the point where we can recognize a face, but not identify which face it is, right? It's not about drawing a green box around a face.
Light.
Yeah.
Yes, TensorFlow Lite at this. Well, there are some processors like the ESP32 does have the ability to do face detection and detect who it is. It's not TensorFlow Lite, that you're using a different like inference engine for that. I think on a microcontroller, I mean, ESP32 is like a 240 megahertz dual core, so I think like, it's doing it maybe like we try it with like 2 frames a second or so. It's not very fast, but it's good enough to just detect if the person's in front. So I think, on some like faster chips like the SAM-A, you could probably do it. So the question is, what is edge? Is edge a Cortex M7 or is it like, a PIC32? So every customer knows where edge is defined for them. But if you're going at the smaller Cortex M4s, and at this time, without additional hardware support, you can't do facial recognition to detect who the person is.
Okay. All right. So, and unless there's any more questions, we kind of started with the TensorFlow Lite. So we've got kind of 2 more things to chat about, and that's CircuitPython in general, and then maybe how you kind of hook that up to make it really accessible into your Adafruit IO framework, because I know a lot of people, or some a lot out there, are intimidated by AWS and by Google, their cloud offerings. It seems to be a lot of overhead for if you just want to get a point-and-click dashboard or something going. And I think there's some compelling reasons why they want to look at Adafruit IO and how well it works with CircuitPython and some of the demos that I've seen obviously being brought up very quickly. So
okay, yeah, we'll kick that off. I'm gonna there was one question that came in with machine learning. That's a very simple one that I can answer fast. Do the models update on the board? Are they static, pre-trained, and loaded? They are static, pre-trained, and loaded.
However, there is some current research going on, and it's going on in branches where you can retrain models. So, for example, the voice recognition model, for example, of saying yes or no, as somebody says the word yes over and over again, it starts to tune the algorithm to better recognize that word. So that, this customization, and this happens definitely with voice agents now. Like they get better and better at detecting your voice by retraining the model. So that's not changing all the different layers. It's maybe just changing like the last layer, and that's something that you can do in the scope of a microcontroller.
Okay, let's gear shift over to Adafruit IO.
Cool.
So how about well, maybe I'll say like things that are important to us.
Yeah.
And then this is where Adafruit IO came out of. So we thought it would be a good idea to have a bill of rights for people. So a bill of rights specifically about your IoT devices, because there's data that's getting shared. A lot of these have microphones. A lot of them have cameras. And who owns that data? It's a sensor. Where's it going?
Yeah.
And so we came up with a thing called the IoT Bill of Rights. You can Google it. We have this. New York Times wrote about it a while ago, and this was way before a lot of, just crazy IoT stuff happening. Also, when you have an IoT device, sometimes the company that made it and sold it to you goes out of business, so you have an IoT device that doesn't work. So we thought, well, since we do open source software and open source hardware, if we do an IoT service for makers to get started, it should educate, it should be easy, but also they should be able to take their data out at any time. They should be able to inspect it. They should be able to do pretty much whatever they want with it. Sometimes they want to share it. Sometimes they don't. They want a public feed so they can do sensor networks and share it with others. Mm-hmm. And so that's where Adafruit IO came out of.
Yeah.
And this is some of the things that were important to you. As you were making hardware, you wanted to have a good service for people to use with the hardware you've designed.
And it works with any device. So we don't care whether it's using Wi-Fi or cellular, NB-IoT. People can use LoRaNet gateways. There's like so many different ways to send data, but a lot of people, they have, you now have a lot of wireless devices. Wireless technology is very inexpensive and it's very easily available. And you want to store that data long-term on a service, maybe plot it over time, maybe because you want to see trends, maybe because you want to use it to train your machine learning model, what have you. So yeah, that's where Adafruit IO comes from. Is it's secure, but it's very simple. And it's not meant for large installations. It's just meant for people who want to get started. Maybe they have like a half a dozen devices they want to track. It's very popular with nonprofits, with students, with scientists, with engineers that are automating their homes, for example, or they have a small startup and they just want to like automate the office and maybe track sensor information. And then as people use it more and more, they get a sense of what IoT is, how to use MQTT and REST, and the kind of behaviors that they can expect from it. Then, of course, they can always graduate to using Azure or Google Cloud or AWS or any of the other, large-scale cloud providers. And in those cases, it's a migration, but the overall method in which you send and retrieve data is not that different. MQTT is MQTT anywhere you go, and so is REST APIs. You just change the URL. But for the most part, you get the same data in and out. So I think it's kind of like like a training wheels, get people going.
Yeah, we have a few goals with CircuitPython, which we do a lot with our IoT service and products, where what can you do in the first 5 minutes to not discourage people? So there's like the hello world with hardware, which is like, oh, I got it to blink. With IoT, we wanted to have something where someone could make something talk to the internet and or get information under 5 minutes. And that sounds impossible because you have to download this framework, you have to download this IDE, you have to get this key, you have to do all this stuff. So one of the projects that we came up with.
Yeah.
And we'll share this.
This is actually the beginner project. This is the first project you do with the PyPortal, which is what we recommend because it's an all-in-one dev board. It'll show off.
Yeah, it also has a screen. And what we found is when people are learning IoT things, if you have a screen that shows what's going on, that's really important because you're fetching data, you're displaying data, and this is grabbing, if you go to adafruit.com, you'll see quotes at the bottom of our page.
Yeah.
And if you ever ordered anything from us, every invoice has a quote on it as well. And sometimes they're quotes from Dune, or they're quotes from visionaries and leaders. Lots of good quotes from Maya Angelou in there. There's a lot of quotes that just little bits of text, and it's in a JSON format.
Yeah.
And
yes, this was our
here's how it's made.
this was our experiment in basically how can we make a device that what it does is it finds, you point it at JSON feed data and it will display it for you. And so this is running CircuitPython, and it's also got a SAMD51, which you kind of need if you're going to parse large JSON files because you just need a lot of RAM to buffer the entire JSON input. Yeah, this is a prettier one. So this way. It's got Wi-Fi coprocessor. It's got a buzzer, SD card, some ports, display. It's got a temperature sensor. This is actually a crypto chip, so it's got sorry, not this one, but one of the other ones has a crypto chip inside.
Yeah, you're looking
of
for
it.
the smaller one.
Yeah, we have the Titano,
There you go.
which is the largest one. We have the Pint, which is the smallest one.
And this one
And
has
then
a
we have PyPortal, which is a medium-sized one.
U-block sensor. And a status LED. So we tried to make it really easy for people to get started. And for example, to set the SSID and password, you plug it in, shows up as a disk drive, and there's a file where you type in your SSID and password. So one of the biggest problems people have with Wi-Fi devices is how do you set the access point and password? It's like nearly impossible for most devices to do that. And we were really inspired by Dropcam. Like that's how we got this idea, because Dropcam, before they were purchased, they had this brilliant idea that when you want to deploy the camera, you'd plug it into your computer and then it would, I think it even shows up as a disk drive, and then you double click an application, the application runs on the device.
Software was on the device, and you were able to get a webcam set up in minutes, and that was probably ultimately why Google bought them, but it was one of the easiest ways, just like when you install Dropbox. I think everyone was calling their company Drop something.
Yeah, it was Drop Time.
The first time you use Dropbox, you're like, whoa, I'm just tossing files over there. It's that easy. And with this,
I'm a huge fan of mass storage for all configuration and
data.
data
We do the
files.
same thing with IoT.
We have not. This
Right.
is the only USB endpoint that we have figured out is mass storage. It's supported by everything. It's like well defined. It's like easy to use. Everybody understands it. Anything else is just so traumatic for people that we really lean heavily on mass storage for configuration. Anyways, so another thing that's really nice is, so this demo shows, again, this demo is maybe like 20, 30 lines, and there's a custom font. There's a text. Oh, sorry. There's an image background, and it does dirty rectangle drawing, so you don't see any flicker at all because the background is a bitmap image, but we're drawing text on top of it dynamically, and it automatically redraws it in like a beautiful, non-flickery, looks like it's double buffered, but it's not double buffered manner. So it's really awesome. Scott worked on Display.io to make it elegant, easy, and it's like really trivial to drag the font file over, you drag the image over, you write 20 lines of code, it grabs the JSON data, parses it out, looks for the quote, and then just displays the text on the screen. So very simple, but this is what most IoT projects do. They have to connect to Wi-Fi consistently, go to a service, get data, do something with it.
Yeah.
Yeah. So,
Right.
so we got this quote demo. So this is the intro demo, and then we got this demo, which is this is really handy. So I like this demo. You can see the REPL shows up when you first boot it, which I think is a cute touch. This is a simple, not a pretty font, just a plain font. This project connects to the internet and gets the time, because you need to have the exact like UTC time. I hope it doesn't not run, because it would be. Uh-oh. Did I unplug it? Hold on. Oh no, I unplugged it. Sorry.
Uh-oh.
It's okay.
So yeah,
Yeah,
I'll
this-
just while they're futzing, I just want to reiterate what Lamar was talking about, the USB just showing up as a thumb drive. It's in a lot of our development tools. If you haven't seen, a lot of our development boards are showing up as thumb drives as well, where you can drag and drop a hex file to program the file. The bootloader is sitting there waiting to interpret a hex file to program it. And again, for those of you who have not seen CircuitPython run on these microcontrollers, again, you're just basically dragging, or that circuit or the .py file, and Lamar and Philip can go into more detail about how that whole mechanism works. But at the end of the day, your IDE is just a text editor that you're just saving that .py file to. And there's some things about caching and things like that Lamar can bring up on the type of editor you're using. But it is a different realm, and I'll get into some other things that I'm working on in terms of source level debugging here in Microchip for CircuitPython. But we'll let them now
Okay.
we got the time up.
I managed to plug it in. Okay, the engineer has arrived, and then they
Okay.
plug in the cable correctly. So this is an example where it actually, so this connects to the internet, gets the time in UTC, and then shows the two-factor 6-digit code for the person who uses this to log in. So because they're constantly logging into GitHub or to Outlook, they just have to, they have this on their screen, and they just select which one they want. It tells them the 6-digit code, and they enter that in when they log in. So it's a very simple user interface, but it's got buttons, it's got a bar, it gets the current time, it does some calculations, and again, it's only like 15 lines of Python code to do all this, to get started with a very basic demo. And every time you want to update the user interface or tweak a color or move a button around, you just edit the text file and just change the X and Y coordinates, save it, and it automatically reloads.
Nice.
So when you're doing very fast iteration cycle programming, so again, this is a far future from when you had UV erasable EEPROM flash chips. You had to put one under the UV, and you had 5 minutes before you could try your program again. Now your iteration cycle is 2 to 3 seconds, which makes a huge difference when you're dealing with IoT stuff, robotics, and sensors, because you have to get the data so quickly and tweak the numbers and do a lot of little heuristic-y things, especially with user interfaces, like getting the spacing and the buttons and the fonts and the colors. It just takes like 20 or 30 iterations. And if those 20, 30 iterations take 5 to 10 minutes per compile and program time versus 2 seconds, like I can usually put together a CircuitPython project in 20 to 30 minutes compared to 4 to 8 hours if I was using C programming, because it's just so much faster to iterate through revisions and fix bugs. And it's got exceptions. Exceptions are the best. So that's a demo number 2. And then the third demo we have, I don't know if you want to go back to us. You want to check out some questions while I plug in this demo, just in case my plugging is.
Can I make a comment? So on the last demo, you were showing the inspirational quotes.
Yes.
I was very inspired. Sent a message to Wayne. So I think what we'll do is we'll buy 3 more of the Edge badges, and if you tweet at us your favorite inspirational quote, hashtag IoT Design Week 2020 at the end.
I love that.
We'll send you the first 3 people to tweet at us. We'll send you.
That's nice.
I'll put that in the chat so you guys know the hashtag.
All right, any other questions in the chat? People, questions about CircuitPython?
Let me go and see if there's anything. No, your questions got answered earlier. Someone wants a Bluetooth router, switch, and hub. I do too.
I'm having no luck with
Would it be safe to say exceptions are exceptional?
They are exceptional.
All right.
Oh, I'm having not very good luck with my
The
demo.
only problems we have today is power.
I'm having I think my hub is dead. This is very sad.
Well, we can use the other power supply. That's
Yeah, I'm gonna get any other questions?
Yeah. I'll
right.
keep an eye on there.
Yeah, sorry.
So for the other thing that we realized when we were doing IoT projects for beginners to get started was having a touch screen seemed to help out with rapid development, because you could start to do menuing items on there and say, okay, here's the information I want to display, here's the other information I want to display. Oh, do you want to go?
Yeah, actually I want to show something interesting. So, because it's like it's just a neat side effect of exception. People are like, why are exceptions so great? So I have this demo, which is, it has a soil moisture sensor that's normally plugged into it, and it's on I2C. And in this demo, I unplugged it because I was like, well, I'm just going to plug in the power real fast. And what's neat is that instead of like airing out or like having to deal with writing a full user interface for error management, it just throws an exception whenever it fails. So like I know exactly where it fails. There's an error code, an error message, what exactly it did not succeed in doing. And then it just says, hey, I'm just waiting for you to rerun. So this is, again, very nice in development, because a lot of engineers, well, maybe only me. I'm the only one who doesn't always check return codes. Everybody else checks return codes perfectly, but I don't. I don't know, whatever. And but it's a common thing. People they always miss one error code, or they're like, oh, I'll get to it later. But what's nice with CircuitPython and other interpreted languages is that they stop you before you start like launching into the wrong sections of memory, before you start getting bad data from I2C because you didn't realize it wasn't actually connected and you're just reading, OFFs and stuff like that. So it's neat to have a little friend.
It also, I don't know if you heard that, it also speaks when it boots up.
It says it's thirsty because it's not plugged into water.
Yeah, right now, if this was connected to our plant, as you can see, the roots are dry. The plant just demanded water.
Yeah, so this is a demo where it's using this moisture sensor, and it reads every few minutes. It displays the temperature and the moisture level, and it also connects to Adafruit I/O. So this is an example where you have a user interface as well as internet connectivity. So now it's too much water. So now that it took another sample reading a few minutes later, it's like, hey, you have too much water, because I was holding on to it. But doing little animations, having nice fonts, having icons, transparent images is all really easy in CircuitPython, so you can get your user interface going very, very quickly. So this was also this is a beginner project. It's like how to make a plant watering system that sends the data over to Adafruit I/O, and then it can send you an email or an SMS message and say, hey, your plants are dying, go water them.
With Adafruit I/O, we also have connectors that work with it, so you can hook this up to if then this that, so you don't have to write all that code. So when it runs out of water, it'll text you or it'll call you on the phone. You can use things like Zapier. You can connect all these things, so whatever triggers you want to make on the other side, time to water plant. You have a lot of choices on how you want to handle that next.
Okay, those are my demos.
Nice.
I did get that working.
Yes, and you, for better for worse, threw an exception on to show how exceptional they are, as
They're
per
so
Philip's
great.
thing.
I actually don't think it should be legal to do IoT projects without exception handling languages, because there's
Like a law? You want a law?
it's a lot of law, because it's actually way too difficult for engineers to handle all the things that go wrong with wireless connectivity. Too much can go wrong, and it's just too difficult to manage without having your language helping you determine that something went amiss. It's just too difficult.
Yeah. Yeah, they're thick stacks and they're not getting any thinner. So I think we can. I think we've covered a lot of stuff, and I think maybe it'd be just to close on the whole concept of if you guys can bring up a screenshot of what a Pi, like a Pi badge, whatever, appears like on a as a thumb drive or a mass storage device, just to show the general layout.
Do you want to plug this
Yeah.
demo in?
I don't know if I can do a screen share though. Can
Ooh.
Yeah, I don't know.
imagine if you would.
Okay, imagine if you will. Okay, yeah. So
I think you can go to our Learn Guides, and we have screenshots of it. But basically what happens is whenever you plug in a CircuitPython device, it shows up as three things. It shows up as a mass storage device. It also will show up as a serial console device. That's the REPL, so you can get live serial feedback on what's going on, and of course type things into it if you want to send it commands. And also HID, so you have keyboard and mouse support, which is really fun and a good way to interface with hardware that you don't control. There's a lot of times where people have to build hardware that interfaces with software or computers that they can't change the underlying software, but HID allows you to mimic keystrokes or mouse commands. So that's a way to do interfacing with other software and hardware. And we also have MIDI support as well. So if you want to do USB MIDI, popular for musicians, but also sometimes used by like lighting or like automation. You'd be surprised. MIDI is an old and well-loved,
It's been very abused
language, a protocol. And I'm trying to think of other things. We're going to add high-speed USB, and eventually we'll have like video. So it'll be really neat. You'd be able to get actual live video stream from it.
One of the things that we learned was
do you have DMX libraries in there yet?
Sorry, what?
DMX.
DMX. Well, DMX. Yeah, DMX. I think someone's working on one, but it's pretty much RS-485. It's not too different than just serial. So I think you can use serial and then toggle a pan when you're ready to send data. But I think people have done DMX projects with CircuitPython. I think I've seen like a couple lighting projects. But that's the nice thing. It's like it's just software. Like we write a library, it uses like a serial port. And another nice thing about CircuitPython, it's all the peripherals are dynamically allocated. So on the fly, you can change what pins you're using and what you're using them for. It requires a lot of support and coding on the back end, but it's a joy to use if you're a user. No looking at data sheets.
Right. And I just wanted to point out for those of you who are not familiar with the, as you're just getting used to the CircuitPython, the libraries that Limor and Philip are talking about are actually coded in C++ and then made
not always.
into. Not always?
No. The libraries are written in Python. They're in pure Python, and then sometimes they're byte compiled down to be compressed. The CircuitPython core itself is written in C. The interpreter
All right, I
itself.
stand corrected.
Sorry, the firmware itself is written in C. So there might be some underlying, there is underlying code. So for example, when you do create a serial port, the code that underneath it finds the circom pins, muxes them, gets the data and shuffles the byte stream you sent to Python to emit, that is done in C using like underlying the peripheral libraries, whatever the chip provides. But above that layer, above the thinnest hardware layer, which is like I2C, SPI, UART, whatever, BLE, the lowest level of BLE, the lowest level of HID, everything above that is done in Python. And we do that for quick iteration, and also because we have a lot more people who are contributing to the libraries because it's so much easier to test and update code in Python than it is in C and C++.
Yeah, I guess I wasn't specific enough. That base layer is in C, so then it builds on top of it. I guess is
Yes.
where I mischaracterized the effort, but
No, it's cool. It's a lot going on there.
yeah. All right. I think, and thank you so much. I think we've covered a lot of ground. And again, I want to thank you. And I'm not seeing any more questions coming up. I'm seeing people submitting quotes.
We are
Lots of quotes.
on Discord 24/7. You can go to discord.gg/Adafruit. There's an entire community of people. Also see Microchip people there all the time. Tomorrow is Ask an Engineer at 8 p.m. where we do another live show.
Yeah.
I want to thank Microchip
Awesome show.
for doing live videos together online where you're sharing
They're ahead of the
electronics.
curve.
So
We
I know
tried.
there's things going on in the world right now, but this was a virtual event that was planned before all the craziness that's going on. But this is a great way to get all this information out and not have to get in a plane. And it's on YouTube, and you win prizes. And so thanks for doing this, because we've been doing Ask an Engineer for a decade, and we're like, this works. Engineers want to watch this stuff.
They do.
So
And get free things.
Thank you
We
for
also
doing
get
this,
free
Microchip. We did this last year with you, and we're looking forward to doing it next year.
Awesome.
Yeah.
Thank you
Awesome.
guys so
So
much.
are we.
It's so great to talk to you.
things. Yay.
Thank
So-
you.
Okay, cool.
So, all right. So I think we're gonna all call this a wrap,
Well,
and Lamore and Philip get to go home.
Sure, I will give a couple house cleaning things.
Oh yeah, we have a few back here as well.
So earlier today, we talked with motion gestures, and actually a lot of the conversation overlapped. They talked about like similar things, but with a different perspective, which is exactly what we're going for. So if you missed that, watch that. And then tomorrow is Security Day,
Yes, it is.
and we'll have Microsoft Azure on, and they'll be telling us more about securing from cloud to edge. And then, if you hadn't got enough Bob, Bob will be back for another double header.
It's all Bob all day.
It is Thursday.
It's all Bob
Maker
all
Day.
day. So
Yeah, Maker Day. We're going to be talking about with web things in the morning, and then in the afternoon.
one things.
Yeah, Bob is going to be showing a demo. So
Yeah.
yeah.
Maximum Bob, if you will.
Maximum Bob.
And and Friday is Low Power Sensor Networks, and that's where we'll be doing our grand finale freebie, which is a ticket to Sensors Expo and a
Yeah,
ticket
that's super
to
exciting.
to Embedded Technologies Conference. So
Yay.
yeah, so make sure you stay tuned throughout the week, and if you haven't tweeted us with that inspirational quote,
We've gotten some really, really good
Yeah,
answers thus
actually,
far.
we have the winners. If you,
Oh, yeah?
Wow.
I can
That was quick.
I can read those off if you want, whenever you're ready, Rachel.
Do it.
Yeah,
Absolutely.
go ahead.
All right. So the first inspirational winner is Bruce Bufford. Quote is, "Everything is impossible until somebody does it." Anybody remember that one? Author?
I don't.
Batman.
Author, yeah.
All right. The second one is from Wade Nee, and the quote is, "Do best."
I like
I-
it.
And the third one is from Armstrong Subero.
Our little friend.
Yes. "You can't become strong by being weak."
Now, who said that one?
So, I don't have any attribution for the last two.
Oh, I think he did in his tweet. I believe he signed it as Armstrong Subero.
Did he?
I believe that's what his intention was.
All
it's
and
a
I
bold
love
move to
that.
quote yourself. I like that.
Oh,
It is
hey.
very bold.
Love it.
You know what? I can live by that.
Absolutely.
So Wayne, should we have them send us an email if we read their?
Yeah,
handle?
the three of you,
Okay.
please send an email to livestream@microchip.com. And, for the three of you, we know who you are. So, if you claim to be that person, we'll know. We'll know that you're not if you claim to be them. So just send an email. We'll respond asking for the correct details we need, and we'll get the free board out to you. For the rest of you, that survey has been in the comments
It's been
on all
dropped.
three
I already
platforms.
see somebody responding. They already finished.
Awesome,
Nice.
Yeah.
awesome. So we will we'll get the names for the winners for that one probably by the end of the day tomorrow. And yeah, Daniel, do we have anything else?
I'm
Very
just
good
gonna
content
throw
today.
in
Yeah,
a
Bob.
little more Bob. Okay, so Friday.
Can never have enough
sorry,
Bob.
Thursday. Yeah. So Thursday morning, my guest is going to be Kathy Jory. She used to work at Mozilla, but she's still an ardent supporter of Mozilla's Web Things, which is another take on the privacy aspect of IoT. And the premise of that is this Web Things IoT framework, which is basically built against a Raspberry Pi. You can download the image from Mozilla.org, and you can set up basically IoT networks within your house, and you are in complete control of the information that gets shared to the cloud, because it doesn't make sense a lot of times to have to talk to a server farm in Cincinnati to turn your light on in your garage, right? And then in the afternoon, my other session is on rapid prototyping. One of my key things within Microchip is bringing together the ecosystems of Arduino and SparkFun and Adafruit, along with Microchip's ecosystems and IDEs such as MPLabX and Atmel Studio. I'm going to mush together an Arduino and a bunch of breakout boards from Adafruit, and a big thank you and shout out to both Philip and Lamore for supplying some really high quality, almost bulletproof breakout boards for all those tiny little sensors that are a pain in the butt to make breakout boards yourself for. I'm going to mash these all together in a air quality sensor transmitting over Bluetooth. All right, so that's what's on tap for Thursday.
All right.
All right. Well, we'll be tuning in.
We're here.
We're not going anywhere.
And
Awesome.
don't forget tomorrow we have a live stream tomorrow. People can watch it after this, and
Yeah.
then
Oh, definitely.
come on by.
Yeah.
Well, thank you, Microchip.
Every week is design
All
week.
right.
Thank you guys.
Thank you
All
guys
right.
so much. I really appreciate
Right.
this. It's been a great day.
All right.
Absolutely, we're ready.
All
to
right.
go.
Thank you.
We'll see you guys tomorrow.
See you tomorrow.
All right. Bye-bye.
It's a wrap.